Okay, class. Before we start lesson today, let's check. Do you memorize 1, 2, 3? And this graph got two parts, which represent what? Okay, so now I encourage you to type your answer. You forgot also, you simply guess, right? At least you have something up. It will help your memorizing. Okay, so I just learned this method called method Feynman. You try to describe it out. All right, so what is the gradient of the graph? Represent. Then what is the area under graph? Under graph represented by this graph. Okay, so gradient is, you say gradient is what? Then area under graph is what? Now please type your answer. Jawin. Jawin, I remember. Jawin. Jawin 没有在。哎呦，我有在啊。汉伦也有在。汉伦你还好吗？有好一些吗？No one can remember. Really? No one can remember? Okay, Jen Sang. Good, good, good. Michelle, good, good, good. Yes, yes, yes. Very good. Only 2%. Really? Only 2%? Hi, Kayang. You can off your camera if you want. Khóc full, correct. But gradient is what? Jia Wen, no, Jia Wen, I'm asking from this graph, what is your gradient? Then what is the area under graph? Okay, but correct lah, Jia Wen, what you say for number 1, correct lah. Okay, like Kai Yang. Okay, it's okay. It's okay. Right, Jen, yeah, correct. Another one. I Han Lun. Yes, correct. Jen, yeah, good. Another one, Kok Chun. Yeah, lah, correct lah. At least you correct lah, second word. Jia Wen, yes, very good. Okay, so far, so good lah. Gradient is spring constant. Yes. Area is elastic potential energy. You must make sure you know it's elastic potential energy, which we have learned in Form 3 science. Okay, good. Spring constant, okay? Or let's say it is a rubber band. Then we say rubber band constant. Okay. Yeah. This remind me that next week I will directly give you a exam type question. It's 15 marks. It will, okay, and Amali is like this. Ujian Amali ujian. It's like this. Sometimes they are not necessary they no need give you spring. They can replace it by using the rubber band. I believe you all see this kind of rubber band before, right? Big rubber band. I believe you all see this kind of rubber band before. But they can replace the spring by using rubber band. Why? Because it is elastic. it has elasticity also. So so that's why I think whether I forgot. I think it's last 2 years. There is one experiment. They change spring to rubber band. Then of course lah. Some people shock, but still can carry out the experiment. Okay, so every step is the same. Just they change the rubber band. And at this time, for spring, we call it as spring constant. Okay, then for rubber band, it's okay lah. We call it as rubber band constant. But actually the same thing lah, understand? Okay, question. Do we have to write rubber band constant instead of spring constant if we use rubber band? Yes, please write rubber band constant. Because spring is spring, rubber band is rubber band. Yeah. What if we don't? Normally we follow schema lah. So if you don't, normally I give wrong lah. But of course, in real SPM, they will have some lenient answer they might accept. But we try to train you in the stricten way. We try to train you in the most accurate way lah. So you might lost this mark in school, but you might, I don't know, you may get 1 mark in SPM. I don't know. Okay. Hi everyone. Okay. Oh, sorry. Okay. So now let's continue. And now this is the 24. Oh, sorry. This is, I think you don't have this. Okay, you don't have this. I don't have it. Spring, 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 spring. Okay, so now let's look at our book first. Page 33. Okay, so Amma carry out of course his graph like this, but our graph is terbalik. Okay, so the graph above shows the extension of spring is directly proportional to the force applied. X directly proportional to F. And the elastic limit is not exceeded. Means, may I know where is elastic limit? Can I know the coordinate of this graph for elastic limit? Thank you, Anas. Yeah, correct. How about others? Okay, to everyone. Okay lah, okay lah. Yeah lah, it's 5 and 12. By the way, you must put bracket. I know sometimes you all shortcut. Yeah, it's here. Elastic limit. What is elastic limit? Can you please tell me the key of elastic limit? Or do you need I give you some hints? It is maximum what? Try simply say something also can. Yes. Thank you, Michelle. Then the rest. Yeah, Jiawen, correct. Very good. Yeah. Try to say something. If you just listen, you will fall asleep one. Yeah, thank you, Jinwen. But one more try. Ching Ching, one more try. Yes, Anas. Yeah, very good. Yeah. So yeah, actually maximum what if not extension means it's maximum force. Maximum force that can be applied to the spring because be, before it cannot return to its original shape. Okay, elastic limit. Then anyone can tell me what is the name of law? Yesterday I showed you. I remember every spring got a yay, Jawan, Anna, Sanjay. Yes. Every at the end of every spring got hooks. Yeah, it's Hooke's law. So Hooke's law actually is the explanation of something with elasticity lah. So if it is spring, yeah lah, extension of spring. If it is rubber band, we say rubber band lah, extension of rubber band. Yeah, anyone can tell what is a Hooke's law? Can you translate? Or you tell me a clue to show you understand? Oh, Jiawen just now could have give a very good full sentence. Yeah. Yes, gentlemen. But how is another half? Gentlemen can yes. Yeah, gentlemen, you should mention elastic limit behind. Yes, yeah. So actually, it's here. Hey, where is it? Here. No. So actually, answer is here. What? Yeah, actually, the answer is here. Yeah. Okay. Okay, so now from the graph, determine the spring constant use. What's your answer? Can I do this? I find gradient. Or I just use this point. So we say F equals to QX. So I use 12 equals to K times 5. I use 12 divided by 5. 5、20、54、20，Newton per cm. Can I? Actually, can if 2 marks. But if 3 marks, you must draw the gradient. And I encourage you, for this kind of question, you can directly draw the gradient like this. But in school, in experiment, I prefer you find 2 points. Okay, for example, this is x2, y2, which is 5, 12. Then you find another point around here. Cannot be too small. If your gradient too small, it is not accurate. Cannot this small, cannot. So please make it larger. Let's say I find a point here. Also looks like too small, that one. Please make sure you get 3/4 of the graph. Okay, so okay, you can take, okay, this point not so good. Okay, when you can simplify a point, but this point not so good. Why? Because can you see the grid? By the way, this line, we call it as graph. This line which you have drawn called graph. Okay, so you can see that actually the graph is not exactly at the edge. 对，它不是刚刚好在 A means it is not really cross the corner. Edge means corner. It is like a little bit not touching to the edge. 所以说它不是刚刚好在尖角的话不要选。Don't choose the point that which is not at the edge line, at the corner. So we continue. Dun, 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 dun. Okay. Now this point. This point is the best. Why? You can see this point ngam at the edge. This one okay, this one don't want. So what is the once you plot the point, please draw a triangle by using ruler. I don't have. Okay, by using this is one of the technique menjawab lah, understand? So actually, it's quite easy to score full marks in graph if you obey all of the rules. Okay, then now let's make the coordinate that is 1, 4, 6, 8, 10 cannot. This is 3. So it will be okay. So I will count in this way. This is 1 minus 0 divided by here got 2.5 division. So I will get I will get 1 divided by 2.5. 1 divided by 2.5. So it's 0.4 lah. So one box actually is 0.4. So this is 2.4. Understand? So you use a value minus another value divided by how many division here. Then you will get this is 0.4 per 1 division. Why 2.4? Okay, that's okay. Okay, so stopwatch. By the way, our school already buy digital stopwatch because this mechanical stopwatch sometimes stuck. Okay, now can you please tell me what is the smallest scale? Smallest scale of the stopwatch means what is the smallest unit that this stopwatch can measure? Millisecond millisecond. 是 milli 吗？no, not millisecond. For this one. Okay, how is it? You might feel confusing, huh? Why 30, 31, 2, 33, 4? Okay, actually it's like this. Can you see the color black and red? So actually this is 0, then 1, 2. So the first round is black. 3, 4, 5, blah, 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 blah. Okay, so 29, 28, 29, 30. Then The second round, you look at the red one. So this is 30. So second round, 31, 32, 33, 34, 35, blah, 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 blah. 57, 58, 59, 60. So actually this stopwatch shows you 60 seconds, but in 2 rounds. That's why it looks confusing. Okay, so now may I know when this stopwatch tak, just tak, one tak only means here. What is the reading here? What is the reading here? From 0, then tak. How many seconds? Oh. Yes, Chen correct. So yeah, actually is now here from here to here. Actually is 0, 1. So 0, 1 minus 0. You use the value, one value minus another value divided by what is the division in between. So the division in between would be, let's count, normally 10. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 division. So it will be 1 divided by 10 division, means 1 division 0.1 second. Now understand why? Why one tak, one tick, tick tock. Yeah, the top tick. One tick is 0.1 second because 0 to 1, in between them got 10 division. So 1 division, 0.1 second. Okay, so now that's why here. So when you feel, oh, it's hard, how to see? Very easy. It's like, see from, okay let's say 2. Let's say 2 minus 0 divided by 5. 5 division, you can see. Now I use another part. I also can use this. 2 minus 0 divided by 0, 1, 2, 3, 4, 5. 5 division. So 2 divided by 5 equals to 0.6. Now see, one grid above is actually 0.4. Okay. Now this is the basic skill you need to learn from maths and physics. Okay. As maths, you are going to draw a lot of graph. Ogive lah, quadratic lah, cubic lah, ini lah. Okay, so now, what is the spring constant? Also, how to get spring constant? Yeah, just now we recall back, actually, gradient is your spring constant. Or we can write like this, spring constant is your gradient. So your gradient is y2 minus y1. You can write down here, okay, divided by x2 minus x1, and you will get 12 minus 2.4 divided by 5 minus 1. So your answer would be 3.4. So answer is 2.4. Okay, so like this, congratulations, you will get 1 mark for gradient, drawing gradient, 1 mark for substitute substituting gradient. And congratulations, get wrong for your answer. Why? 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 Why wrong? Why? Yes, thank you, gentlemen. Other than German, German. Yeah, no unit. But I forgot the unit. Oh no, Hannah. I forgot the unit. How? Alamak, I forgot the unit. Oh. Yeah, correct. Yeah, thank you, Michelle. Thank you, Jill. Yeah, correct. Yeah, actually, just look at your y-axis and x-axis. You must write. So from here, we can see our unit. Just substitute back lah. And also, this remind you to write the unit when you draw the graph. Understand? So this one actually is Newton per cm. So you join it back by using indices knowledge, index knowledge, like x over y equals to xy power is -1. But of course, in physics, we don't sound that in, like in maths, we sound that like Newton per centimeter, all right? We write short, but when we speak it out, we must speak out the full one. Newton per cm. Okay. So if 3 marks, congratulations, you get 3. And if 2 marks, also can like this. Okay. I still encourage you to use gradient, okay, to play safe. All right, so now calculate the energy stored in the spring when it's extended by 4. When it's extended by 4. So it's here. So this is the area on the graph. And or we can use the formula. What's the formula? Forgot how? How? I forgot. Oh my god, I forgot. How? I forgot. Oh my god. Yeah, correct. Half fx. If you panic, suddenly cannot remember. It's okay. Check your formula in front. Understand? Half fx or half kx squared. Since you got k already. Okay, then we will get half fx and we can substitute f is 12 and x is 4. And I'll get the answer 24 joules. Yeah, correct, correct, correct or not? Yeah, thank you, Jalen. Very good. You noticed it. Yeah, sorry, answer wrong. Your substitution also wrong. Last time lah, now I can feel the schema is like they are like more strict. Last time if you substitute 4, okay, you still can get 1 mark lah. Okay, but now if you substitute 4 wrong, they also give you wrong. because you didn't substitute correctly. Joules is in SI unit. So you must E equals to half Fx. F is in Newton. Congratulations, correct, Newton. X must be in meter, but this is cm, so actually it's 0.04 meter. And we will get 0.24 joules. Okay, so I hope you all can memorize this till the trial. Okay, till the trial. Okay, then so please for physics please make sure you do and check answer. I think I will photostat the answer for you because last year we still got some money left. It's about 1% around 1 ringgit something. So I will use that to photostat. And you all will get the answer. Then so please have the habit. Once you try, when you finish, do your work, don't stop there. Check answer directly. Teacher, the 4 isn't connected to 12. The 4, oh yeah, my fault. Sorry, my fault. Yes, you are right. Yeah, sorry. See, careless. Hey, very careless. Thank you very much. Yeah, it's 4. Very good, very good. I'm testing you. No, I really wrong. Yeah, so 4 is, how, what is this number? Yeah, so actually it's 0.4, 0.8. I mean 8.4, 8.8. Then this one will be 9.2. This one will be 9.6 because one division is 0.4. So 9.6. So sorry, my fault. Really, my fault. Sorry, my fault. Yeah, that's why. Please check your answer. Yeah, so it's 9.6. My fault. It's 9.6. So answer is 0.192 joule. Okay. Yes, yes. Thank you. Thanks for reminding. I really overlooked. Okay, so see, if you check answer directly, you know lah, which part you wrong lah. Is it you wrong by using 12 or you wrong by not changing cm to meter lah? Then this one, a spring, and 2 of the spring is carry bra. So what is the extension? Okay, so how? First of all, a spring can see by 10 Newton. So we draw lah. For me lah, I draw like this lah. A spring 10 Newton. So it will extend x4 cm. So you imagine if we increase to 30 Newton, what happened? Of course, longer, right? So x equals to times 3, 12 cm. Or you can use back the formula. You can use this one called proportional method. 10 Newton for cm, so 30 Newton times 3 lah. This is proportional method times 3. This one also times 3. Or you can use back your formula F equals to Kx. And then this is same spring, means the spring constant K1 equals to the spring constant K2. Like you do simultaneous equation in your maths. So we can say K1, so K actually equals to F over X. Same spring will have same spring constant, all right? So we say K1 equals to K2. So F1 over X1 equals to F2 over X2 lah. So you can substitute F1 is 10, X is 4. So F2 is 30, X2 is how much? So you do your cross multiplication, you arrange them, and you will get 12 cm also. Okay, so yes, Hooke's law also can be applied by using this way, proportional method. Because why? Because same spring, they got same spring constant. You can use proportional method, or you show it in this way. F1 over X1 equals to F2 over X2 lah. Okay, but the problem is, yesterday we learned, right? What is the arrangement of this spring? Can you tell me? Yesterday we learned LDDMA, right? A. What is this arrangement? Series or parallel? Which one? You can type S or P lah. Yeah, thank you, Jiawen. Yeah, thank you, Anas. Yeah, 100 correct. The rest, forgot. Okay, parallel means berat sama di pikul. Okay, so this berat sama di pikul by 2 spring. So how do we count the extension? So we will use original extension divided by number of spring. N means number of spring. So original extension for 30 should be 12 cm. But now we got 2 spring. Berat sama di pikul. So 2 spring divided by 2. So we will get 6 cm. So extension of the spring 6 cm. And must read question properly. If they ask for what is the length of the spring, you must add the original one. Right here. Okay, no problem. Yeah, no problem. Okay, bye. Yeah, I know you got tuition. Got some of you got your plan. Okay, I know not everyone can join on the spot. So okay, take your time. Okay. Okay, so now this one, okay, now we look at this. Actually, I gave this in the WhatsApp group already. It's the Last time, one Afifa didn't print all out lah. Didn't print all out, just print a part, few pages. I'll resend this lah. Nah, this is bab 1, not this one, bab 1. I resend this. How to resend? How to resend? Forward to okay, so actually just I think we just print out until 20 lah. Until 20 or 2019. So this is actually behind. Okay, then this is last year. Last year set 1, Selangor set 1. Okay, hello, bye-bye. Thanks for telling me. Okay, so our SPM trial normally will buy from the Selangor government. I mean, sorry, Selangor, JPN, Jabatan Pendidikan Negeri. So it will have set 1 and set 2, same concept, but different question. So now we can see this is a man sitting on a compressed spring mattress. Name the type of energy stored in the spring when it is being compressed. I believe you know it, so I skip that. When the man in diagram 9 gets up from the mattress, it is found that the mattress returned to its original shape. Explain why. Okay, this one we skip first. Okay, now this one. The length of spring Q in diagram, spring Q means one of the spring. One of the spring. So in this treat, it is one of the spring. Okay, so the length of the spring Q in diagram 9 is 16 cm, where the spring constant for spring Q is this. Calculate the length of spring Q if the load 200 Newton is applied to compress it. So, essay normally you answer on the test bed lah, but now you can like do like this and see what. How? Okay, so if you have no idea, please write info first. Or you want to write here, okay? I encourage you to write info first. So 16 cm is, spring constant is, calculate the length of the spring if, question mark, the load 200 Newton. May I know what is 16 cm? What is this? What is this? In front, what should I put? We recognize first if you have no idea. I 口春可以吗？这个是什么？ What is this? What should I write in front? K 呀，不是啦，这不是 K 啦 ，K 是这个啦。K means spring constant means you need to use 2,600 Newton of force, then only you can direct it become 1 meter. Okay. Okay, the length of spring Q. So actually this is original length. Then, okay, so load 200 Newton actually is a force lah. So what do they want? They want length of the spring Q. So means length 1. Okay, so it's like you will understand better when you after you do the experiment. So, okay, is it the one? This nuts. Where is my spring? Wait, where's my spring? I think I deleted. Oh my god. Yeah, oh, I show you first. Like, next week when you all do experiment, this one is, so see, original length is from here, is from here to here, let's say, so it will be 48 cm. So this is original length. Then when you put on the weight, then you will get this one. This one is 56 cm. So what is 56 cm? Your L1. Okay, so what is your X? L1 minus L0. This is extension. So if compression, also actually the same thing. 7.69 cm. Okay, so this is L1. Then I think you understand. So, right? Then how? So we use F equals to KX first. We get X lah. So from here we also know that X equals to L1 minus L0 ma. So the long one minus the short one ma. If compression, X equals to L0 minus L1. So we get X first, then we minus back compression. Okay, so F200, K 2600, X. Then we will get X equals to, so 0.0679 meter. Because this is in meter, so you will get it in meter. So you can change to cm lah, because your original is cm. So you will get 7.69 cm. If you can do up to here, actually info no marks, but info helps you to figure out. So if you can get here, you will get 1 mark and 2 mark, but you will lost the third mark. May I know what is your third mark? Yeah, correct. So your third mark actually is what is your L1? So L1 would be compressed means original will be shortened. Nah. So you will get 16 minus 7.69. So 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 8.31 cm. Then you will get correct. Yes, thank you, gentlemen. Thank you, Anna. 2 decimal point is fine, or do we need to take more? Okay, it's like this. Your original decimal is actually your original answer is 4 decimal places. Then you change to 2. Okay. Or original you want to like original number you want to take like 0.076923 meter. Then you change to 7.6923 cm. Also can, because your original is 4 meter, then change to cm, then 2 decimal places is okay. Okay, or you want to do this, you make 4. Oh, lagi bagus. Okay, then you will get 4 decimal places here. I encourage you all put more than 3 4 for decimal places. Okay, so now determine the compression of the spring if 2 spring Q is arranged in series and are subjected to the load of 200 Newton. So now it's like this, 2Q series. Then you put 200 Newton on top. Just now is 1Q, only 1 spring Q, you put 200 Newton on top. Then you will get compression, this one, X. Then you will see it compressed, and finally this one become 8.31. So now, what is the compression of spring? Means what is the total X for these 2 springs? Can we apply the berat sama typical? Ringan sama dijunjung? Can we apply that? No, because it is only applied on side by side. This one is, they don't hold each other. So some more they increase the force to direct it down. So actually it is, this is X plus this is X. Original X are. So original X is this one. So we use 2 times X. 2 times 7.69 or 7.6923. Then we will get so the total extent, the total compression would be 15.3846 cm. Total compression. The compression means it becomes shorter. Extension means it becomes longer. Okay, now last. Which one is the best to be your mattress? You might ask, teacher, what is the difference of inner spring and pocket spring? Never mind. You don't understand, you look at, yesterday we learned LDDMA. For what? For to produce a mattress that is able to withstand heavier load and only compress on the part is pressed. Means a heavy person sit on it, the spring can tahan. Okay, if don't look at the type of spring. These 3, how? LDDMA. Actually means what? Means this one, heavier load, means you want stiffer spring or you want more elastic spring. Yay, thank you, Anas. The rest. Okay lah, I know lah. Yeah, thank you, Junman. Okay lah, I know lah. These two words still not in your mind lah. Let me explain. Stiffer means hard to pull or hard to compress. But don't remember this. Remember stiffer. Okay, more elastic means easy to pull or compress. Always say soft. Don't use soft. We use elastic. So now, what do you think? Can you get your answer ready? Is S of E? Is A S or E? Beside Anas and 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 Chen. Yes, Cochrane, yeah, correct. Anything, just guess. Okay, the answer is stiffer. Stiffer means K spring constant is higher. So you need more force to compress. Then it will. So stiffer means extension of the spring or compression of the spring is shorter. Then you imagine, do you want your mattress when you sit down, it directly go to the ground? We don't want to, if like this, why we buy the spring mattress, right? So we want it support us back. So actually we want what? We want shorter X. Shorter X means stiffer, means spring constant high. And I tell you, I very know this because I tried this two before. Okay, now stiffer. So which one? Diameter of LDDMA, diameter of spring wire and diameter of coil and material of the spring. Seems like this one is the easiest. Steel or copper? Thank you, Anas. Thank you, Cochrane. Correct. Think back your chemistry, alloy is stronger or pure metal is stronger. Yeah, thank you, Jiangmin. Yeah. Okay, good. Yeah, it's steel. Okay. So means copper cannot already lah. Means these two, this cannot already lah. Okay, right now, can you recall what is diameter of spring wire and diameter of coil? Okay, so can you translate? Diameter of spring wire we also call what of wire? Yeah, thickness of wire. Yeah. Okay. Bye, Jaden. Okay. Bye. Sorry. Okay, thickness. So thickness should be bigger lah, so that thicker lah. So answer is L lah. Okay. Diameter of spring coil, you remember the slinky spring, the girl drop it down, very elastic. Big diameter of coil, elastic, don't want. So we want, sorry, don't want big, yeah, so don't want big. So small lah, small, so it's one big lah. Then pocket spring is better because pocket spring, when you compress here, this part won't dent. So how? So if this is the queen size bed, one person get up. So all of the spring independent, so only this part will compress, this part not. So won't catch out each other. Okay, so you can try this one. Maybe you just try on your book. You can try this two lah. This the spring mattress, and then this the bowl. Very good example. If you can do or you have done before, you will get the idea lah. The answer I will send also, you can do and check answer. Okay, so that's all for today. So next week we do experiment lah. Okay, thank you everyone. Bye bye. Oh, if you have any question, can stay back. Okay, bye bye. Bye. Okay. No question, no question. I end the class. Okay, bye.